Hi, welcome to the video for lesson 4.5 on the bivariate normal distribution. Let the random variable y denote the grade point average of a randomly selected college student. Then we might want to determine the probability that a randomly selected college student has a grade point average between 3.0 and 3.5. That is, what's the probability that y is between 3.0 and 3.5? Now, if we think about it, we can imagine that a student's college grade point average is related to his or her high school grade point average. Presumably, students with higher high school grade point averages would also tend to have higher college grade point averages. And if that's the case, then in calculating the probability that a randomly selected college student has a grade point average between 3.0 and 3.5, it might be useful to first take into consideration that individual's high school grade point average. That is, we might want to answer a question like, what is the probability that a student's grade point average is between 3.0 and 3.5, given that their high school grade point average is equal to 2.5? In order to answer this type of question, we are going to need to find the conditional distribution of y given x. And we are going to look at a special type of model that we can use if we're willing to make certain assumptions. If we're willing to assume that y follows a normal distribution, that there's a linear relationship between x and y, so the expected value of y given x is a linear function of x, and that the variance of y given x is constant for all values of x, then the conditional distribution of y given x is going to be normal. And the mean and the variance can be found by these formulas here. Now, the first formula for the mean is just the formula for our least squares regression line, because we're assuming that there is a linear relationship between y and x. Then this would tell us the mean of y for a given value of x. And the variance formula is derived in the book, but it's equal to the variance of y times 1 minus the correlation squared. So if we know the mean of y, the mean of x, the variance of y, the variance of x, and the correlation, we can calculate the mean and the variance of this conditional distribution. Let's take a look at an example. Okay, so we're going to suppose that the individual student's college grade point averages have a normal distribution with a mean of 2.8 and a variance of 0.2. That the mean of the high school grade point averages is 3.1, and that the variance of the high school grade point averages is 0.22, and the correlation between individual students' high school and college grade point averages is 0.72. Now, we can calculate the probability that a randomly selected college student has a grade point average between 3.0 and 3.5 by using the fact that y has a normal distribution. And if we standardize 3.0 minus 2.8, that's our mean, divided by the square root of 0.2, there's our standard deviation. And we standardize the value of 3.5 minus the mean 2.8 divided by the standard deviation, square root of 2. This is equivalent to finding the probability that a standard normal random variable takes on a value between 0.45 and 1.57, and we can use our tables to find that that's equal to 0.2681. Now, if we're given the fact that a student's high school grade point average is 2.5, what is the probability that their college grade point average is between a 3.0 and a 3.5? We know that the conditional distribution of college grade point averages given high school grade point averages is normal because we've made these assumptions. And so we have these nice formulas we can use to calculate the mean and the variance of that normal distribution. So if we plug in our values from the problem, we get a normal distribution with a mean of 2.39 and a variance of 0.096. Now, if we want to calculate the probability of a student having a grade point average between 3.0 and 3.5, given that their high school grade point average was 2.5, we're going to standardize again, but this time we're going to standardize using the mean and variance of the conditional distribution. And then we can use our tables and find that the probability is equal to 0.0242. So far we've assumed only three things: that y follows a normal distribution, that the relationship between x and y is linear, and that the variance of y is the same for all values of x. If we add one more assumption, which is that x also follows a normal distribution, then x and y have what we call a bivariate normal distribution. So x and y, both of their marginal distributions, have to be normal, which also means the conditional distribution of y given x is going to be normal, the conditional distribution of x given y is going to be normal. Let's work through an example. Let x and y have a bivariate normal distribution with parameters: mean of x equals -3, mean of y equals 10, variance of x equals 25, variance of y is 9, and the correlation between x and y is 3/5. If I want to find the probability that x is between -5 and 5, I'm going to use the fact that with a bivariate normal distribution, both of the marginal distributions have to be normal. So x has a normal distribution. We know that its mean is -3 and its variance is 25. So I can standardize, use my z-table, and find this probability is equal to 0.6006. If I want to find the probability that x is between -5 and 5, given that y is equal to 13, I'm going to find my conditional distribution, g of x, given that y is equal to 13. I'm going to use this nice formula to find the mean and variance of this distribution, which I know has to be normal. If I plug in the values from our problem here, I should find that this is a normal distribution with a mean of 0 and a variance of 16. So if I standardize now using the conditional distribution, I can find the probability is equal to 0.7887. Part C asks to find the probability that y is between 7 and 16. Now again, since we have a bivariate normal distribution, y has a marginal distribution, which is normal. Its mean is given here as 10 and its variance at 9. So I can standardize using these values and find that the probability that y takes on a value between 7 and 16 is 0.8185. And finally, for part D, calculating the probability that y is between 7 and 16, given that x is equal to 2. To do this, I need to find the conditional distribution of y, given that x is equal to 2. This is our h of y, given that x is equal to 2. I know that it has a normal distribution, and I can use the formulas to find the mean and the variance of that distribution. If I plug in the specific values for our problem, I get a normal distribution with a mean of 11.8 and a variance of 5.76. Now to calculate this conditional probability, I'm going to standardize using the conditional distribution and then use my z-tables to find this probability is equal to 0.9371. That brings us to the end of the video on the bivariate normal distribution. I hope it's been helpful. If you find that you have questions, please don't hesitate to ask. Thanks.